So continuation, part 2, still an overview of compute. What is scaling? So we'll be getting into what is scaling. So scaling defines adapting resources to actually manage any increased demand. So there are two types of scaling that we'll be going over: vertical scaling and horizontal scaling. So vertical scaling, which we refer to as scaling up and down. What is it? This means that we are expanding the capacity of a single instance, something like upgrading a car to a faster engine. So something like that. Uh, it's suitable for applications that aren't distributed, things like traditional databases. So speaking of a call center, for example, as an analogy, vertical scaling is like hiring someone who is highly experienced and can handle more calls uh, in a call center. We are increasing the capacity. In terms of horizontal scaling, scaling in and out, this involves adding more instances rather than enlarging one. So vertical scaling, we are enlarging it. Horizontal scaling, we are adding more instances. And we use auto-scaling groups, which automatically adjust the instance count as demand changes. Now, and also we are going to use load balancers, which will enable us to distribute traffic now that the instances have been added. So as our call center analogy, I said vertical scaling is like hiring someone who is more experienced and can handle more calls, while horizontal scaling is like adding more workers to handle calls simultaneously. We also have a concept of high availability. What is high availability? High availability focuses more on keeping systems operational even if part of the infrastructure fails. So this is achieved by deploying our application in multiple availability zones. Now think of it as having a backup office somewhere. If it's our call center, we have a backup office in another city. That means that if one office becomes unavailable, the other office will continue operations, ensuring there are minimal disruptions. So high availability, we are in when talking about EC2, high availability, we use multi-AZ auto-scaling groups and multi-AZ load balancers to help distribute traffic across those availability zones, hereby minimizing the impact of any potential outages. So this is high availability is crucial and essential for critical applications where downtime is very costly, such as something like an online retail platform or so. So now we'll get started with load balancing. As I mentioned, with load balancing, we are distributing traffic evenly across multiple servers. So we have our auto-scaling setup, our auto-scaling group. In this auto-scaling group, we have our instances. So maybe 1, 2, 3. As traffic increases, our instances increase. Now we'll have someone who knows where to direct people, and that is what we call, not people but traffic, and that is what we call the load balancer. So the load balancer will be somewhere over here. When user 1 tries to access our application, the load balancer says, okay, I direct you to this specific instance. User 2 comes in, tries and accesses our application. They are directed to the second instance. User 3 comes in, they are directed to the third instance, and so on and so on. So maybe user 4, they are directed over there, and user 5, they are directed to the fifth instance. So that is the purpose of a load balancer. And why do we use a load balancer? We want to spread load for better performance and reliability. We also want to provide a single point of access to applications. So our access, we just point them to the load balancer, and the load balancer will know how to distribute traffic evenly. A load balancer will also do some health checks to make sure it only sends traffic to instances which are healthy. So it does not send traffic to instances which have failed. Load balancers also offer SSL termination to enable secure communication. So for example, checking the server certificates, translation from HTTP to HTTPS also. And load balancer also offer high availability because they can distribute traffic across multiple availability zones. So what are some of the load balancers we have available in AWS? An elastic load balancer in AWS is a managed load balancing service that simplifies the setup and management. So AWS will ensure high availability for us, automatic scaling for us, and that means that we require minimal configuration, making it easy for us as users to deploy without worrying about any infrastructure upkeep. So we have different types of load balancers. The first one is classic load balancer. This is the original option of the load balancer, not really used at this point in time, deprecated, but still available on the console. It's the original option, and it supports load balancing for HTTP, HTTPS, and TCP traffic. So it worked at both layer 4 and layer 7 of the OSI model. This is best for simple applications with minimal requirements. We have the application load balancer, ALB. It's more advanced than the CLB, so it's a newer version, latest version. It's ideal for web applications, and it only supports HTTP, HTTPS, and WebSocket protocols. So the application load balancer works at the application layer of the OSI model, that is layer 7. We have the network load balancer. Network load balancer works at the layer 4 of the OSI model, so the transport layer, and it supports TCP and UDP protocol. So this is great for high performance TCP and UDP applications needing very minimal latency. And now we have the gateway load balancer. This is special. It's specialized for network layer use cases, so layer 3 of the OSI model. It's kind of commonly used in conjunction with security appliances like firewalls. I did a demo before on the gateway load balancer, so you can check it out in my YouTube channel, an overview of the gateway load balancer. So let's do a quick demo of the application load balancer, see how we create an application load balancer in AWS. So back to my instances, still under EC2, you scroll down, you'll get the load balancer and create load balancer. So you see the options we have, application layer and gateway load balancer. The classic load balancer is available, but it's the previous generation. So I'm going to create an application load balancer, give it a name. PJ application load balancer. It's an internet-facing load balancer, supports IPv4 traffic, network mapping. Which VPC will it be? So I only have the default, so I'll go with the default VPC. And the mappings, so I can select all the availability zones available within that that span that VPC. And now a load balancer needs to have a security group. So you need to set up a firewall that defines which traffic is allowed. So you can use the default security group or create a new security group. So we are going to go ahead and create a new security group for our load balancer. Our load balancer is going to allow maybe HTTP traffic. Yeah, so PJ, the load balancer SG security group, and the load balancer will allow HTTP traffic from anywhere, and you are going to edit it according to best practices. So it belongs to the default VPC. I'm going to add a rule which allows HTTP from anywhere and create this security group. So coming back here, I'm going to refresh this page. So we are going to select our security group, the PJLBSG, and the listener. So which port and protocol will it be listening to? So it allows HTTP and HTTPS. So it listens on port 80, and where is it going to distribute that traffic to? So once traffic comes in, what is the target of this traffic? So we can go ahead and create a target group, even though it won't have any instances for now. We'll just create an empty one. So the target will be instances. What is the target? So it will be instances. This will be the JLBTG target group. IPv4 from the default VPC, health checks. So I leave everything as default for the target group. And you can register targets or not. So I'll just create an empty target group. So it does not have any registered targets. And select that target group. Cool. So that's it. And then I'll go ahead and create my load balancer. And here it is. So it's provisioning. It will span multiple AZs. And now the next thing is the auto-scaling group. So with the auto-scaling group, the cloud allows flexibility with resources, enabling you to scale your applications very easily. So think of auto-scaling. We have an automatic worker that adjusts the number of EC2 instances based on the demand that your application is facing. So we have in auto-scaling, we have the concept of scale out and scale in. When we scale out, we are adding more instances or adding more servers when the load increases, for example, during peak hours. When you are scaling in, we are removing servers when the demand decreases. So that means that we are optimizing on our cost and resource usage. So some of the key benefits or the key features of the auto-scaling group, or key features, you have to set up your minimum and maximum EC2 instances, because we don't want to go over cost, and you need to register the new instances with a load balancer to ensure that the load balancer is able to distribute this traffic to this auto scaling group, and it will automatically replace any unhealthy instances. It's also free. You pay for the EC2 instances that you create. So some of the key benefits too: cost efficiency, because you are only paying for the instances that are running; elasticity, because our application will grow and shrink as the demand comes in. So auto scaling automatically reacts to maintain performance. Okay, and then we have what is the configuration needed when we set up our auto scaling group. So we need a launch template. A launch template is just like a recipe, for a dish in the kitchen. So it defines the ingredients which you need. In this case, we are talking about an EC2 instance. Our launch template will define things like the instance type, the user data, the security group that you need for each EC2 instance. So once you have a recipe for our EC2, you can keep preparing the dish over and over without changing the ingredients in it every time. And then we have the capacity settings. So capacity settings, this is like setting up the maximum number of orders maybe your kitchen can handle during peak hours. So you define the minimum, that is the minimum number of instances that will run, the maximum number of instances that can be launched in that auto scaling group, and the desired capacity. So at this point in time, when I'm creating this auto scaling group, what is the ideal number of instances that I want based on the current traffic? So the auto scaling group will always stay within these boundaries, making sure if, for example, it's a restaurant, we need to make sure that we want to avoid running out of food, and we also want to avoid maybe staffing too many cooks. So these are the maximum number of cooks we can have in our kitchen. and the minimum. So something like that. And then you also need to set up your scaling policies, which define how you're going to scale. So speaking of scaling policies, we can use CloudWatch alarms. We'll talk about CloudWatch later. And we need to set up metrics like maybe the CPU utilization went above 80%, so add an instance. So a scale out will be triggered when the CPU is too high, or a scaling triggered when the CPU is too low. Speaking of scaling policies, what are some of the scaling policies that we have available? So we have dynamic scaling, where we automatically adjust based on real-time metrics. So this is like having a manager who just watches the number of orders coming in and adds or removes cooks as needed. So if the order suddenly increase, the manager will go on and bring in more staff. If the order kind of decreases, they will send the cooks home. So that is dynamic. We are automatically adjusting based on the real-time metrics. So under dynamic scaling, we have three types of scaling: target tracking, step scaling, and scheduled scaling. So how does it happen? With target tracking scaling, an analogy, we can say that in our kitchen, we want to maintain a specific cooking temperature. So if your oven is running too hot, the manager will adjust the temperature. So maybe adjust the temperature to become colder. Or if the kitchen is too cold, the manager will automatically increase the heat. So the goal is to just keep the kitchen temperature just right. Now, speaking of our EC2 instance, if your EC2 instance is maybe running too hot, it's going over high CPU, the target tracking scaling will automatically adjust the by scaling out. So, by scaling out, that is adding more instances to handle the capacity. If the CPU is too low, for example, maybe 40%, the target tracking scaling will automatically remove the instances which are not needed. So an example is keep the target at around 40%. So we are just saying 40% is a good CPU utilization. If it maybe goes above 60, an instance is added. If it goes below 20, an instance is removed. Step scaling. Step scaling, we have a fixed number of instances based on some condition. So here is now we are like maybe we are setting up, if it's for example our kitchen, we are adding extra help in increments. If the number of orders increase above 20%, 20 maybe 20 dishes per minute, add 2 more cooks. If the order goes below a certain threshold, maybe 10 dishes per minute, remove 1 cook. So we have a fixed number of instances. So in this case, we are saying that if it's CPU, if the CPU utilization goes above 40%, add 1 instance, and if it goes below 40%, remove 1 instance. We have a fixed number of instances. And then we have scheduled scaling, very easy. We want to pre-schedule scaling actions based on predictable traffic. So it's like predicting when to prepare for a busy night. If you know like Fridays at 7 p.m. will be busy, you can pre-schedule more cooks in advance. Similarly, in auto-scaling, you can prepare your instances to handle expected traffic patterns like scaling up before a non-peak period, like a holiday sale or any special event. And then we have predictive scaling. This is now uses machine learning to predict any future load and schedule scaling. So it's like having a seasonal focus. And if the restaurant maybe knows summer is coming and people are reaching out more, they'll prepare ahead of time to handle the increased traffic. So predictive scaling uses historical data and machine learning to focus the future load and scale accordingly, making sure you are always ready before our traffic spikes. So let's create an auto-scaling group. So go over an auto-scaling group demo, see how we create one and attach it to our load balancer. So back, so for auto-scaling group, an auto-scaling group needs something first. It needs a launch template, our recipe that defines if the auto-scaling group is to add more instances or reduce more instances, how does it go about it? So you can create a launch template and specify your own Amazon machine image. I'm going to use the Amazon machine image from the Linux server that I have created because I want this page, the instance metadata, availability zone, and I also want to do some CPU load generation. So how to create your own AMI? Go to your server and under actions, image and template, create an image. So you can create an Amazon machine image. I'll give it a name. So this is for my auto scaling group, AMI, and so that's it. And I'll go ahead and create this image. So currently creating this AMI from my instance. So now, because I'm creating an AMI from my instance, it will come pre-installed with all the things that this instance have. So it will come with this application in it. I don't need to use a user data script in this case. So it's currently creating. I can go to images, look at the AMIs, and I can see the AMIs owned by me. So this one, it's a private AMI. It's still in the pending state. And now I want to create a launch template using that AMI. So create launch template and give it a name. So it will be a launch template for my auto scaling group, LT. So template version, launch template for my auto scaling group. So I am going to use it for auto scaling. So I need guidance to help me set up a template. Now for the Amazon machine image, you can use browse AMIs or use your own AMIs. Because I created one, I'll select my AMIs which are owned by me, and I'll choose the PJ auto scaling group AMI which I created from my instance. Next, instance type and all the settings. So you can see the settings are similar to, creating an EC2 instance or so. So instance type, I can say don't include in the launch template, or maybe say all the instances should be T2 micro in that case. So I'm creating a recipe. Now, if the auto-scaling group is going to launch instance, this is the recipe I need for my instance. If I will need to create a key pair, you can, I won't include that in the launch template, but if I need to SSH to your instances, you can create a key pair that will be used by your instances. Subnet settings, you can decide which subnets you want. So you can specify which subnets you want, or don't include that in your launch template. And the security group that the instances will use, you can create your own security group or select an existing security group, and also the VPC. So in this case, I'm going to create a security group for my auto scaling group, and that is the security group that will be used by my instances. So under security groups, create security group. So this is PJ ASG security group. And this one allows HTTP access, but I want to be very granular. So this allows HTTP access only from the load balancer. So we don't want any users to just access my server. So we can only access our servers from the load balancer. So in the default VPC, and I'm going to add a role. So allow HTTP traffic as long as that traffic is coming from. So I'll select custom and select the load balancer security group I created. So PJLB load balancer and create security group. So I'm going to use that security group in my launch template. Select existing, PJ autoscaling group servers SG. So volumes, general purpose is okay. And I'll create a launch template. So these are basically the configurations that my servers will use, which will be created from the autoscaling group. Okay, now that we have a launch template, we go ahead and create an autoscaling group. Give it a name, PJASG. Which launch template is it going to use? The launch template I created. And you can see the definition. So it's this launch template. It's using this AMI. It has the security group attached to it. They will be T2 micros. I click next. Instance type requirements, T2 micro, that is okay. The network, so the VPC it will be in, and the subnets that you want your instances to be created in. So I'm going to select all the available subnets, 2A, 2B, 2C, 2D, and just balance, best effort, availability zone, distribution. Next, I'm going to attach it to an existing load balancer that will distribute traffic to my autoscaling group. So I'll choose the load balancer I created. So choose from your load balancer target group. I created a target group for my load balancer, and whether I want to perform health checks. So I can say I want to turn on elastic load balancing health checks so that the load balancer will only send traffic to the instances which are healthy. So that is the only setting I'll change. And yeah, next. So group size. What is the desired capacity? So I can say three instances for now. The minimum capacity is 1 and the maximum capacity it can launch is 6. So that means that even if my CPU utilization goes beyond 100%, the autoscaling group will not launch more than 6 instances. And then you select a scaling policy. So in this case, I'll go with the target tracking scaling policy. And I'm saying my average CPU utilization should be maybe 50%. So if the CPU utilization is going above that, the autoscaling group will automatically add more instances. If the CPU utilization is going beyond that, it will automatically remove some instances. So maybe I can say the target value 80%. The average CPU utilization will be, or maybe 70 is better. So instance warm up, so I'll set up the default for 300 seconds. That is the time the autoscaling group will wait for the EC2 instances to warm up. So maintenance policy, I leave that as default. And next, I don't want to add any notifications. So I want to add tags to the instances that will be created. So they will be named. The name of the instances will be PJSG servers. So this is a server created from my autoscaling group. Review, and once everything is okay, you create your autoscaling group. So here it is. Our autoscaling group is being created. The desired capacity is 3, minimum capacity is 1, maximum capacity is 6. Now, if you check in the activity section, you will realize some activity is happening. So T2 micro is not supported in your requested availability zone, US West 2D, no worries. But so launching a new EC2 instance, so there is an EC2 instance being launched, and So a user created an auto-scaling group, changing the desired capacity. Now it was 0. Now they are trying to create 3 instances. So 2 instances are being created already. And if we go to our EC2 instances, we should be able to see them being created. So instances running now are 5. And you can see PJSG server, they are initializing. So when you look at the PJASG servers, one is in US West 2A, another one in 2B, another one in 2C. So they are being initialized and they are being created by our auto-scaling group, and they are attached to our load balancers. So let's wait for them to initialize. So updating capacity to 3. And we have target tracking policy selected. So you can select other types of policies, for example, predictive, scaling policy, or scheduled action from here. Instance management, you can see the number of instances that have been created, and all of them in US West 2A, 2B, and 2C are healthy in this case. So let's see if we can access the server. So this one has a public IP, but it should time out because our security group does not allow just anyone to access the server from its public IP. Our security group, we said the server should only accept traffic if that traffic is coming from the load balancer. So that means that we can only access the server from the load balancer's DNS. So I'll go to the load balancer, PJ application load balancer, get the DNS name. So this one can't be reached, but let's check our load balancer. Okay. Oh, we are not getting the instance ID details. Maybe I can do some little bit of edit there to the instances manually to make sure we are getting the instance details. So EC2. So it's because I missed the advanced details section. I should have edited the metadata. So, but this should have been done from the launch template. Okay. Metadata version 2 is optional. And the last server. Oh, cool. So let's see if we'll get the instance details. Cool. So you can see the load balancer. We are using the load balancer DNS. The first instance that responded to us was from US West 2C. If we refresh this page, the second instance is from US West 2A. And if another user tries to access, they get a response from US West 2B. So the load balancer is kinda doing a round robin over here, distributing traffic evenly across the multiple instances. So I want to generate some load on the instances, see if the auto scaling group will create more servers. So start CPU load generation for the first instance. So I'm trying to stress it. So current CPU load is 100% in US West 2C. Let me go to another AZ, US West 2A. So CPU load is 3%. Let me stress this one too. This is under high CPU load. So it's also hitting 100% CPU load. US West 2B is also under 100 CPU load. And the third instance, let's see, US West 2A. Okay, so we can see the instances right now. The desired capacity has changed from 3 to 5. So let's look at the activity section. And what's happening over here. So an instance was trying to be launched at US West 2D, which is not working, but it's okay. So launching a new instance, a monitor alarm target tracking alarm high is in state alarm triggered. That means that the target tracking policy is changing the desired capacity from 3 to 5. Why? An EC2 instance was started in response in difference between the desired and actual capacity. So it's trying to launch new instances. The ones in West D are failing, but that's okay because the ones in the other availability zones are fine. So if we go to our instances right now, so we have 1, 2, 3, 4, actually 5 PJ ASG servers. So we have 2 more initializing in that state. So that is how an auto-scaling group works. Once you set up your policies, it will automatically, add or terminate servers. And that's it for auto-scaling and load balancing. So in the next bit, we'll cover other compute services that are available apart from EC2. So see you in the next time.